Hello class, today we are going to learn about the adaptive immunity, specific defenses of the host. In general, there are two types of immunity, innate and adaptive. Innate immunity refers to the defenses that are present at birth. Unlike innate immunity, adaptive immunity is designed to recognize self from non-self, and it mounts reactions that are specific to the particular substance or pathogen at hand. The cells and the chemical factors involved in adaptive immunity came into play when first and the second line defenses of innate immune system falls. The first time these cells and the chemicals encounter a pathogen, response can take days or longer to develop. However, adaptive immunity system also has a memory component, which engages future defenses against the same pathogen much more quickly. Adaptive immunity is described as a dual system with humoral and cellular components. Humoral immunity primarily involves B cell and neutralizing threat outside human cells. Cellular immunity primarily involves T cells and deals with threats inside cells. Both involves a specialized immune cell receptor that recognize antigen, followed by activation and production of cell, chemical messengers, and other factors that help destroy the antigen in question or allow the body to remember it later for speedier future interactions. Antigen, substance that cause the body to produce specific antibodies or sensitized T cells. Antibody, proteins made in response to an antigen and combined with antigen. Serology, the study of reactions between antibodies and antigens. Antiserum, a generic term for serum because it contains antibody. Globulins, serum proteins, immunoglobulins, gamma globulin, serum antibodies. Proteasome electrophoresis is a classic analysis method for serum proteins. Proteins of different properties in serum samples can be clearly separated to form different zones. Its chemical structure is highly uniform, so its electrophoretic mobility is very constant. Generally speaking, the four bands from negative to positive are albumin, gamma, beta, alpha, and the last three are all globulins. Based on function, the organs and the tissues of the immune system can be divided into primary or secondary lymphoid organs and tissues. The primary organs or tissues are where immunonature lymphocytes mature and differentiate into antigen-sensitive B and T cells. The thymus is the primary lymphoid organ for T cells, and the bone marrow is the primary lymphoid tissue for B cells. The secondary organs and tissues serve as an area where lymphocytes may encounter and bind antigen, which triggers their proliferation and differentiation into full-act, antigen-specific actor cells. The spleen is a secondary lymphoid organ. The lymph node and the mucosal-associated tissues are secondary lymphoid tissues. There are different types in human blood cells. Pluripotent stem cell in the bone marrow divide to form a two blood cell lineage. First, the common myeloid progenitor cell gives rise to the erythroblast that produces erythrocytes, megakaryocytes that produce platelet, an unknown precursor that gives rise to mast cells, the granulocytes, monocytes that give rise to dendritic cells, and the macrophages. And the second, the lymphoid progenitor cell give rise to the natural killer cells, a separate lineage of dendritic cells, the B cells that become antibodies secreting plasma cells, and the T cells. Note that dendritic cells can arise directly from myeloid and the lymphoid progenitor cells and from the non-proliferating monocytes. Thank you for your attention.